Think about how a government treasury operates. Only one treasury controls the money. Everyone accesses the exact same entity to make deposits or withdrawals, because multiple independent treasuries trying to manage the same currency would break consistency. You rely on this concept of singular control without a second thought. In software engineering, that same logic is applied through the Singleton Pattern, a structure used to manage shared resources in almost every production environment. To see why we need it, look at this tangled, naive architecture. Without a managed pattern, developers hard-code class instantiations wherever they need them. The trouble starts the moment requirements change. Every new case forces you to crack open existing working code, which violates the open-closed principle. Unchecked instantiation creates a fragile system that is difficult to test and maintain. A disciplined single-access gateway protects code integrity by centralizing object creation into a single, predictable path. The intent of the Singleton Pattern is specific. It ensures that a class has exactly one instance while providing a single global access point to retrieve it. This UML diagram maps out the strategy. We separate the part of the code that stays stable, the single instance rule, from the application logic that varies. We let them talk through a clean abstraction seam. Strip away the jargon, and Singleton is one idea. Only one instance globally, a single guarded gateway. This structural seam is what provides the design with its flexibility. We can map every element of the government treasury analogy straight onto the code. The physical treasury building acts as our singleton, and the guarded teller window maps directly to our holder abstraction. Once you see this direct relationship, the pattern stops feeling like an abstract theory and starts feeling like a mechanical tool. Let's build this from scratch. Here is our foundational singleton class. It begins with a private constructor and a static instance variable, ensuring no outside class can trigger a new instantiation. But consider this. What happens if two concurrent threads hit this null check at the exact same millisecond? They will both evaluate to true, and both threads will create an instance. You've just broken the rule of singular control. We can solve this by adding a synchronized block to lock the creation process. Only one thread can enter at a time. This works, but locking creates a performance bottleneck every time the instance is requested. To fix that, we use double-checked locking. We add a second null check inside the synchronized block to verify the state, and use the volatile keyword to ensure the instance is visible across all threads the moment it's created. For a modern lock-free alternative, you can use the Bill-Pugh holder method. By placing the instance inside an inner static class, the JVM handles lazy, thread-safe initialization for you without explicit locks. Managing execution state at the exact moment of creation is the only way to protect a global instance's integrity under heavy load. The pattern offers operational benefits: strictly controlled access, lazy creation saving system resources, and a unified global access point. However, global access creates hidden dependencies. Components relying on this global state make unit testing difficult, and state can bleed between test cases. Engineers should introduce a singleton only when the architectural flexibility it provides outweighs the friction it adds to the testing suite. This pattern is historically justified for specific use cases: managing configuration objects, centralizing loggers, or governing shared caches and database connection pools. Modern development often favors passing instances through dependency injection to avoid the testing friction singletons can create. Choosing between the two requires balancing the need for a global point of contact with the need for modular, testable code. Remember the core hook: only one instance globally, a single guarded gateway. Internalizing this mechanism helps you identify where global state is managed. When you encounter a central manager in a complex project, you'll recognize the structural guardrails that keep that object unique.